Hello everybody, welcome to another Flow video. This is Jacob Tucker, and in today's video I'm going to be showing you how to work with attachments in Cadence, what they are, and some cool stuff you can do with them. Now before we get started with this video, I just want to say that I know that my video is not working. I forgot my camera at home actually, and I hope that's okay. This video will be somewhat quick, so I don't think you'll miss me too much. Um, but yeah, so this is a new feature that's coming to Cadence. In fact, it's actually live on a test emulator version, which is what I'm going to be using to show you today. It's not on testnet or mainnet yet, but it should be in the next fork. So this is going to be a big update to Cadence that I think is really important. Thus, why I'm making this video. So first of all, I'm gonna put a link to this GitHub README in the description. This overviews all of the attachments feature, why we need it, how to use it, what you can do with it, all that. But this video is basically a video version of this text. So I hope this helps. Now, also before we get started, I want to give a massive shout out to C3P Flow, who actually submitted a hackathon entry that uses attachments for the recent Flow hackathon that happened. And I'm actually going to be using part of this example to explain this to all of you today. So thanks, C3B Flow, for coming up with a super helpful, easy to understand example of attachments. Um, okay, so that was the intro. So let's say in Cadence, right? And by the way, this video assumes that you have some prior understanding of Cadence, right? Because this is going to be pretty technical. So let's say in Cadence you have an NFT, or really it can be any resource or any struct. For the purposes of this video, I'm going to be using an NFT. What attachments are is they're basically little we'll think of them as circles that you can attach to a resource or a struct, or in this case our NFT. So you can have a bunch of them, but the important thing to note is that attachments, you can only attach one of each type to the NFT. So let's say this is some type, we'll call it like A, we'll call this one B, and this one C. You cannot attach two C's. So for example, if we were to make another one here and try to attach it, and this one has type C, then this is going to fail. So this will not work because we already have a C that is attached to this type. Um, so this is like a very basic understanding of what attachments are, and I'm going to show you in code what this kind of means, and I think you'll understand it with an example. So if you don't understand what the heck I'm talking about yet, just give it a sec. So, okay, so just keep this in your mind even if you don't understand this yet. So, I'm going to make a contract that allows us to basically add a RPG character to any non-fungible token resource. So for the purposes of this video, I've deployed a example NFT contract. This is literally a bare bones NFT contract. It doesn't even have metadata views in it. So you should understand what this is before you even touch this video. And if you don't, you can check out the rest of my channel to understand this. I actually have a video on the NFT standard. And I also have the non-fungible token standard contract right here. So very basic code so far, right? And what I'm going to do is make a contract called RPG that allows us to define a RPG character attachment, okay, attachment that we can attach to any NFT type. So first of all, let's make a contract called RPG. And I'm going to make a attachment. So you know how a resource is defined like this? Actually, let me increase the font a little bit. Public, a resource is created like public resource test, or a struct is public struct test. Well, an attachment is created by saying public attachment, the name of the attachment, and then you have to specify what you are attaching this kind of thing to. So non-fungible token.nft will say. Oh no, I think it's actually 4. Yeah, it's 4. Okay. I'm as you can see, I'm getting used to this as well. Um, so we have to import the non-fungible token contract, which I'm going to do right here. And now we're fine. So what the heck does this mean? Well, this says that we're going to define an attachment type called RPG character that can be attached to any non-fungible token NFT. Now, I want to make a quick point that attachments can be resources, they can be things you attach to resources, they can be things you attach to structs. So it'll just automatically take the type of whatever you have here. So because non-fungible token NFT, as we all know, is a resource type, this means this is an attachment for a resource. But if we had defined a struct, let's say we had made a struct called test, we could also say for test. So It's the same thing. Now this will be a struct attachment. It just takes the type of whatever you're defining it for. And what this means, this for thing, is that, for example, we can't attach this to a fungible token vault, right? It's only for non-fungible token NFT and its subtypes. Um, that's important to know. So besides that, attachments are very, I mean, they're pretty much identical to resources or structs in the way you define them. So we can have stuff in here like a name. We can have a class, which I'm going to define in a second. And you, of course, have to have an initializer just like you do for a resource or a struct. So we'll pass in a name, which is a string, a class, which is a class, and we'll say self.name equals name, self.class equals class. And I'm going to actually just make a very simple class enum that just says you can either be a warrior, you can be a archer, or you can be a soldier. Okay, so pretty simple stuff. Um, cool. So what is the next part? Okay, now one thing I want to mention that I think is super cool is, and maybe this will be familiar to you if you've worked in languages like Solidity or maybe other languages, but one thing that's super cool is you can actually access the functions and variables on this type inside of your attachment. So let's say we want to add a function here, and you can also have functions inside of attachments called print ID. You can say log, or let's say just get ID because this will work on non-emulator networks. We can say return base.id. Now, base is a keyword used to access this type. So it's super cool, and actually, we can probably even let thing equals base. It'll probably even show us the type. Yeah, so you can see here that the base type is a reference to a non-fungible token at NFT. So super cool stuff, right? Um, but yeah, so just note here that the same rules apply, like for access control, the same rules apply here. So and what I mean by that is if we go to non-fungible token, which is the type that is right here, you can see that we can access the ID, right? Because it's public let ID, and we're able to access that right here. However, let's say we had another function called, let's just delete this for now, called get letter, or I don't know, some random thing like this. And let me just show you what I'm trying to do here. Let's say inside of non-fungible token, we have an access contract let letter. That's a string, right? Because this is access contract, which means we can only read it inside this contract. Look what happens if we try to do base.letter, right? It's not going to work. It's going to say cannot access letter field as contract access. So it's important to note that access control applies here as well, in the same way it would for normal structs or resources as well. So that's just a quick note. Okay. So pretty cool. So what we've done so far is we have defined, right, like we'll change A to RPG character, right? This is essentially what we've done so far is we have an RPG character type attached to an NFT. And the point I was trying to make over here is that, we can only attach one RPG character at a time to the NFT. Okay, so we can't have something like this where, we have two RPG characters attached. We can't do this, right? So this in this case, this would not be allowed. Only one at a time. Okay, so let's actually go through the process of attaching the thing to the resource. Now, as far as I'm aware, you can only, just like resources, you can only create them inside of the contract they're defined. You can only attach attachments to their respective types in the contract that's defined. So we actually have to make a function called attach RPG character to NFT. And we're going to pass in a non-fungible token.nft. We also need to pass in a name, which is a string, and a class, which is a class. And then we're going to return the non-fungible token.nft that we pass in back to the caller. And actually, let me just format this a little better. Also, I apologize if you can hear me breathing heavily in the mic. I've been having pretty bad asthma recently. Okay, so what we're going to do is we pass in the NFT. We're going to then create an attachment inside this function and then return the NFT back to the caller. However, with this time, this NFT will have the attachment on it, okay? So what we can do is we can say return um, arrow, because we're working with resources, right? Because it's a non-fungible token NFT. Return attach RPG character, and we pass in variables the same way we do with a structure resource to arrow NFT, okay? So what this does is this attaches an RPG character to the NFT type and then returns that back to the caller. Now, just because some people like to look at it in 2 lines, this is the exact same thing. Oh, uh, okay, never mind. Okay, you have to do it in this one big line. Yeah. Um, yeah, so this is how you would do it. Okay, so attach RPG character to NFT. Okay, pretty cool. And now again, this NFT will have the attachment on it. So that's awesome. So let's actually go to a transaction, and let's attach the attachment to the NFT. So far with this transaction, this is just a very, very basic transaction. It looks a little complicated, but it's not, I swear. All it does so far is take in a description, name, and class. We need a name and class because that's what we're going to pass into our attachment right here. And we also pass in a description because we need that for our example NFT that we define right here. Just because I want to show you how to access variables and stuff like that. Um, and besides that, in our prepare statement, we just say, okay, if the signer does not have an example NFT collection, just give them the collection, link it properly, and then get a reference to that collection. And then we're on this line, we're just creating the NFT. So in my example NFT contract, I just have a function to create the NFT here by passing in the description, and it gives you a NFT back. Okay, so pretty simple. And that's the NFT right here. So next, let's actually go ahead and attach the attachment to it. So what we're going to say is let RPG NFT arrow because it's a resource, and we're going to say RPG.attach RPG character to NFT, which we just defined, right? We have to move our NFT into it and class. What is wrong here? Oh yeah, because we're working with enums, by the way. Uh, the this function is expecting a class. However, it's hard to pass that in as a transaction argument, so I just pass in the raw value. So the way you actually do this is you say raw value um, class, and you just simply say rpg.class, I think. Oh yeah, and then exclamation mark. So this will take the raw value. So for example, this is 0, 1, and 2. So this is 0, this is 1, and this is 2. These are raw values. And if we pass that in right here, 0, 1, or 2, it'll convert that to the actual class. Okay, that's just a side note. So cool. We now have the RPG NFT, and now what we're going to do is we're going to say self.collection.deposit, and we're going to move the RPG NFT into our collection. Okay, pretty cool stuff. Yeah, so this should attach the the RPG a RPG character to our RPG NFT, and then we're going to store that inside our collection. So let's actually go ahead here. Sorry, I was doing a lot of testing beforehand, as you can probably see. But let's go ahead and start our emulator, and then I'm going to run a transaction. Oh, let me actually deploy the contracts, and then let me go ahead and run a transaction so that all of you can see it. To do this. Okay, so flow transaction send. We're running the attached transaction. I'm going to pass in description. The name, I'm just going to say it's a warrior thing. And we're going to pass in, well, let's see. Warrior is actually 0, so let's just go ahead and pass in 0, okay? Boom. So we send the transaction. Awesome. So now that we've done that, let's actually go ahead and try and view our attachment or our NFT, okay? So again, I've defined a very basic script. All this does so far is get a reference to the user's collection. Then it says borrow auth NFT. All that does is it goes in the collection and it just borrows a reference to the full example NFT, right? And that goes right here. Now it's complaining we're not returning anything, so to get rid of that error, let's just return test. Um, and cool. So what do we want to put in test? Well, I want to show you how to read an attachment and also how to read the resource here. So let's just go ahead and let's try and read the description in the NFT, which we should all know how to do. It's very easy. Let's try that. Public description is a string. In it, let's just go ahead, define this, self.description equals D, and that's pretty easy, right? So we just have to pass in NFT.description. Very easy because we have let's actually write this out here, right? We have a reference to an example NFT.NFT, which obviously has a description right inside of it, so that's pretty easy to get. Next, let's actually try and get the attachment stuff. So let's try and get the name and the class. So we can do that but we have to get the attachment first. So the next question is, how do we get the attachment on our resource? Okay, so the way to do that, let's say let a equals NFT, and you actually use these bracket syntax, and you pass in the type of the attachment. So rpg.rpg character, because that is the type of our attachment right here. And this will return an optional. So in this case, we can actually just return a test optional type, and we can say we can actually use optional binding to say if there is an attachment, then we can return all of our test stuff. However, if there isn't, then we'll just return nil. Okay. So if there does exist an attachment on this NFT, then we'll just go into this block. If there doesn't exist this attachment on the NFT, we'll just return nil. Okay, this is very helpful. If you wanted to check if your resource or struct has an attachment on it, this returns nil if it doesn't have the attachment, obviously. So very helpful stuff. Okay, so yeah, so now let's go ahead and let's also try and return the name and the class, which is an rpg.class type. Let's add that here. I just use this syntax because I think it's super helpful, the underline syntax. Self.name, it's just a lot quicker to write. Self.class equals class. Okay, and we have to pass it in now. So it's actually super easy because now we have a reference to an RPG character, which has a name and a class inside of it. So we can just say a.name and a.class, and we're done, right? And if we wanted to, we could also do like get ID, and we can just log this. So this is an example of how to call a function. It's actually very similar, right? So all this should be coming together. So let's go ahead and run the script now. We see that the ID of the NFT that was minted was 24. So I'm passing in 24 here and the address it was minted to, and this is what we get. So we get description, warrior thing, class is the class here. And if we go to our emulator, we all see that it logs 24, which is coming from this line, right? So this was 24 in that case. So super, super awesome stuff, right? Super awesome stuff. Now, one thing, oh yeah, one more thing I want to show you, or a couple more things. How do you remove an attachment? Well, we can actually try this together. So let's try and say, let's make another function called remove RPG character from NFT. Okay, we can shorten this a little bit. And this is actually pretty simple. We can just say remove RPG character from NFT and then return NFT. And it's that simple. Now, by the way, a attachment also has a built-in destroy function, just like resources do. So you can put like some destroy logic in here, and destroy gets run when it is unattached. So once we run this remove, the attachment gets destroyed. Okay, and you can put some logic in here. And what's pretty cool, by the way, is you can also access base inside of destroy. So you can do that right here. Remember, base is this type. Okay. Cool. Now, one thing I actually want to test, I'm going to do this with on video. I actually don't really know, but I want to try and see if you can remove outside the contract. Can you remove RPG character from RPG NFT? Let's try. Oh, looks like you can. Okay, so unlike attachments, where I think you have to attach inside the contract, at least for inside the contract, you can remove outside of it, which is pretty cool. And I'll prove that to you here. I actually tried this earlier. Let me try to like if we try to attach, let's see, let RPG NFT. Yeah. So I don't think. Yeah. See, it doesn't. Oh wait, maybe you can. Wait, what? Oh, maybe I was totally wrong actually. Oh, okay. Never mind. I'm a total idiot. So, okay, I was wrong. By the way, you don't have to attach inside the contract. Okay, that was totally wrong by me. Um, I'm glad I just did that. Okay, so not true. You can attach inside transactions as well. Okay, cool. I'm glad that I corrected that. All right, so one more thing I want to show you is, oh yeah, so Um, One important thing to note here is that when we go to our attachment, you'll see that this says we can attach it to any non-fungible token NFT. So this actually works pretty well, right? Because we can attach this to any non-fungible token NFT or any of its subtypes. But look what happens actually. And when we go to view it, right, when we say NFT at RPG character, this syntax compiles, or this compiles, um, because we know that an RPG character can be accessed on any subtype of non-fungible token NFT, which is also example NFT, right? However, if we were to change this to example NFT to NFT and say, wait a minute, we can only attach this attachment to an example NFT, right? Let's change some of the syntax around. Okay, so we can only attach to example NFT. Now, if we go here, this still works, right? Because we're able to access it on our example NFT. However, let's say we casted this to a non-fungible token .nft. Okay, let's say we casted it. Uh-oh, this no longer works because um, we're not sure, right? This is only attachable to example NFT. And in this case, not all non-fungible token NFTs are a example NFT, obviously, right? They could be flovatars, they could be floats, doodles. So this syntax won't work anymore, and this won't compile. So just remember that we can only access or check to see if there's an attachment if it's for that specific or in that intended type. Okay, so I hope this was helpful for you. And if you have any more questions, feel free to ask in the Emerald City Discord. And that'll be in the description. And I'll also link this for you to read if you want. So thanks for watching. Hope this was helpful, and peace out.